Okay, so we want to determine the pressure in psi of ethane at 115 degrees Fahrenheit and a specific volume of 0.3. Now, again, we're going to use this compressibility chart. Hopefully you have your book, because it might be a little hard to see on here. Okay, but we're going to use this compressibility chart, again, because that's how we relate pressure, temperature, and volume to one another. Now, as we move forward, we'll actually move into ideal gas model, but for now, let's start with this idea. Okay, so remember, in this chart right here, we need the reduced temperature, which is going to be my current temperature over the critical temperature, and I also will need well, they're given the volume, so I'll actually need the pseudo reduced volume. And if you don't remember, that's given from the equation V over RTC over PC. Okay. Now, we've got to look up a few things, right? We need, for ethane, we need to look up the critical temperature, critical pressure, as well as the molecular weight, because we need to get R instead of R bar. Okay, so let's start with the temperature. Okay, so I'm going to go to table A1. Okay, and I'm going to go down to ethane. Okay, and you see that my critical temperature is 549. My critical pressure is 482, and that's in atmospheres. Okay, and my molecular weight is 30.07. So we're going to use those three values for ethane to calculate these things. So again, my temperature, and I'm going to need this in Rankine, so it's going to be 115 plus 460 divided by, again, 549, that was in Rankine, and I get a reduced temperature of 1.05. Now for these values in here, I have 0.3, and again, that's cubic feet per pound. The R I'm going to use is actually the 1545, because I have things in pounds per square inch and cubic feet per pound. So I want the foot-pound version. So it's going to be the 1545 R bar. Okay, so that R is 1545, and again, I'm going to divide that by the molecular weight for ethane, which I just looked up, which is 30.07. Okay, so that's R. I'm going to take that times my temperature, which critical temperature, which again is 549, and I'm going to divide that by the critical pressure, which again is 48.2, but that's in atmospheres. So I need to multiply that times 14.7 to get it into PSI, because there's 14.7 PSI in every atmosphere. And then I need to get it in pounds per square foot, so I can get everything in feet, because again, my volume's in feet. This is in foot pounds. So I need to take this times 144 to go from square inches to square feet. Then all of this is going to give me my pseudo-reduced volume, which is 1.08. Now, using the temperature and the volume, the reduced temperature, the reduced volume, I can use this chart in the back of the book, the compressibility chart, to calculate what Z is. Okay, so I'm going to go to the chart, and you can see my temperature lines go this way, and here's the 1.5 or 1.05, excuse me, temperature line. Okay, my volume lines go this way, and I'm at 1.08, so I'm going to follow this 1.5 or 1.05 all the way to 1.08, which is going to be right about here on the chart, which I'm going to call Well, it's just close enough to 0.75, right? Because as I drag this over, my Z value is 0.75. So I'm going to use that, okay? Okay, and remembering that my Z is PV over RT, okay? So now knowing that Z is 0.75, I know my volume, I know my temperature, I can now calculate my pressure at this point. So through the magic of plugging in numbers, being careful with my units like I was up here, but to save time I'm going to skip all that, and I find that I get a pressure of 513 pounds per square inch, or PSI. Okay, so again, that's how you use the compressibility chart. You figure out reduce temperature, volume, pressure, depending on what you're given. Use the chart to calculate Z, and then from Z, plug everything back in and solve for whatever it is that you're looking for. Now, again, moving forward, we probably won't be using this a whole lot. We'll next move into the ideal gas model, where Z approaches 1, which is where a lot of the gases that we're going to be dealing with are housed in this course.